So we were talking about PSW registers. PSW register is a bit and byte addressable register. This register reflects the status of operation that is carried out in the controller. It determines bank selection by RS1 and RS0. The physical address of PSW starts from D0H and the individual bits are accessed with D0H to D7H. Now the carry flag. The carry flag is the one which generates a carry. कोई भी हम एडिशन कर रहे हैं उसमें अगर कैरी जनरेट हो रहा है तो कैरी फ्लैग हाई सेट हो जाएगा, दैट इज 1. हमने दो नंबर्स का एडिशन किया और अगर लास्ट बिट का एडिशन में कैरी जनरेट हो रही है तो यहाँ पर कैरी फ्लैग जो है वो हाई हो जाएगा. देन comes the auxiliary flag. The address of auxiliary carry is D5. This is affected when a bit is generated from third position to the fourth position. अगर यहाँ से पोजीशन इधर से अगर कैरी जाए 1+1 इस पोजीशन से इस पोजीशन पर अगर कैरी जा रहा है तो ऑक्सिलरी फ्लैग जो है वो सेट या रीसेट होगा. अगर ऑक्सिलरी फ्लैग की वैल्यू 0 है तो इट इज रीसेट. If it is 1, it is set. Then for overflow flag, the address of overflow flag is D2. When a bit is generated from 6th position to 7th position, then the overflow flag is affected. If it is 0, the flag is reset. If it is 1, the flag is set. Then the parity flag. The address of parity flag is D0. While performing arithmetic operations, if the result is 1, then the parity flag is set, otherwise it is reset. RS1 and RS0 are the bits which are used to select different memory locations, that is bank 0 to bank 4 in the RAM. अगर 0 0 है तो bank 0, 0 1 bank 1, 1 0 bank 2, 1 1 bank 3, इस तरीके से. Now the memory mapping in 8051. Memory interfacing is used to provide more memory space to accommodate complex programs for more complicated systems. Types of memories which are most commonly used to interface 8051 are RAM, ROM and EEPROM. 8051 can access 64 KB of external memory. It can be to understand, it can be explained as total number of address lines in 8051 are 16. Therefore, it can access 2 to the power n, matlab 2 to the power 16, which comes out to be 65535 locations, जो होता है 64 KB. So, it can access 64 KB of external memory. यहाँ पे डायग्राम के हेल्प से आपको बताया गया है लाइक दिस. जितने भी मेमोरी है उनको मर्ज करके हम 8051 फैमिली में 64 KB से एक्सटर्नल मेमोरी कनेक्ट कर सकते हैं. देन नेक्स्ट कम्स RAM memory space allocation. In 8051 there is total 128 bytes of RAM and inside 8051 they are assigned the address of 00 like this 00H to 7FH. ये पूरा जो मेमोरी लोकेशन है ये रैम को असाइन किया गया है. 32 bytes from 00H to 1FH, this one इतना पूरा they are assigned to register banks and the stack. 16 bytes from 20H to 2FH are set aside for bit addressable read-write memory. 80 bytes from 30H to 7FH locations are used for read and write storage and it is called scratch pad. These 80 locations RAM are widely used for purpose of storing data and parameters by 8051. Now talking about the ports. We know there are in all 4 ports. Port 0, port 1, port 2 and port 3 in 8051. We have seen this in the pin diagram also. Pin number 32 to 39 is assigned to port 0. Pin number 1 to 8 is assigned to port 1. Pin number 21 to 28 is assigned to port 2, and pin number 10 to pin number 17 is assigned to port 3. अब इसमें हर किसी का अलग अलग तरीका है काम करने का. So we'll see what is their function. 8051 has 4 important ports, namely port 0, port 1, port 2 and port 3. These ports allow microcontroller to connect with the outside world. The 4 ports of 8051 microcontrollers have certain specific functions and corresponding features also. Port 0 is characterized by 2 functions. First of all, it is located from pin number 32 to pin number 39 in all 8 pins. To use this port as both input-output port, each pin must be connected externally to 10 kilo ohm pull-up resistor. When the external memory is used, then the lower address byte is applied on it. Else all the bits of this port are configured as IO ports. When P0 port is configured as output, then other ports consisting of pins with built-in pull-up resistor connected by its end to 5 volt power supply, the pins of this port have resistor left out. For input configuration, if any pin of this port is configured as input, then it acts as float. Float matlab the input has unlimited input resistance and is indetermined potential also. आउटपुट कॉन्फ़िगरेशन में अगर हम उसको कनेक्ट करते हैं, then the pin is configured as an output, then it acts as an open drain. By applying logic 0 to port bit, the appropriate pin will be connected to ground, and by applying logic 1, the external output will keep on floating, will be coming in. In order to apply logic 1, 5 volt on this output pin, it is necessary to build an external pull-up resistor in this way. उसके पास में अपने हर एक के पास में 10 किलो ओम के पुल-अप रेजिस्टर्स होने चाहिए. Then port 1 is true IO port as it doesn't have any alternative function as in port 0. But this port can be configured as general IO port only. It has a built-in pull-up resistor and is completely compatible with TTL circuits. उसको बाहर से अलग से pull-up resistors देने की ज़रूरत नहीं पड़ती है. Port 1 is dedicated IO port and the pin numbers are 1 to 8. Upon reset, it is configured as output port. It is generally used for interfacing to external device. Thus, if you need to connect to switches or LEDs, you could make use of these 8 pins, that is port 1. But it does not need any pull-up resistors as it is internally having those pull-up resistors built in it. जैसे पोर्ट 0 में हमको एक्सटर्नली लगाने पड़ रहे थे, in port 1 there is no such requirement. For port 2, it is similar to port 0. When the external memory is used, pins of this port occupy addresses intended for external memory chip. This port can be used for higher address byte with addresses A8 to A15. When no memory is added, then this port can be used as general IO port similar to port 1. Like port 1, port 2 also does not require any pull-up resistors and it occupies pin number 21 to pin number 28 position. Then port 3. In this port, functions are similar to other ports except that logic 1 must be applied to appropriate bit of port 3 resistor. It is also dual purpose, but designers generally avoid using this port unnecessarily for IO because the pins have alternative functions which are related to specific features, or I can say special features of 8051. Indiscriminate use of these pins may interfere with normal operation of 8051 because it is similar to the function of other ports also. However, for a programmer, it is Same to program port 0, port 1, port 2, port 3, everyone. All the ports upon reset are configured as output. To use any of the port as input port, it must be set to programmed. Now, the next one. These are alternate functions of port 3 that can be performed by port 3, like receive data for serial port, transmit data, external input, external interrupt. There are two external interrupts. Then timer counters are also there. External data memory, write strobe and read strobe is there. These are the external, or I can say alternate functions that may be performed by port 3. So it is not unnecessarily used by the programmer. जो function port 0, port 1, port 2 कर रहे हैं वापस से उसी के लिए the programmer does not use port 3. These are the alternate functions that can be done. Now, next is I/O port structure. 8051 microcontrollers have 4 I/O ports, each of 8-bit, which can be configured as input or output. You can see the internal circuitry. This is the internal circuitry. We'll come back to this. Hence, total 32 input-output pins allow the microcontroller to be connected with peripheral devices. The pin can be configured as 1 for input and 0 for output as per the logic state. If you want to read in from a pin, you must first give a logic 1 to port latch to turn off the FET, that is transistor. Otherwise, the data read in will be logic 0. When you write to the port, you are actually writing to the latch. For example, a logic 0 given to latch will be inverted and turn on the transistor, that is FET, which causes the port pin to be connected to ground, that is logic 0. For input output pin, all the circuits within the microcontroller must be connected to one of its pin except P0 port because it does not have pull-up resistors inbuilt. For input pin, logic 1 is applied to a bit of P resistor. The output transistor is turned off and the other pin remains connected to power supply voltage over a pull-up resistor of high resistance. Now this is the internal structure for IO port, where the triangle and this line, these are the different latches. This is the transistor and this is a port. This is the latch where you can write something and this is for reading. This is the internal structure for IO port. That is all for today's lecture. If you have any difficulty, we are going to get it solved in the discussion session. Thank you very much.